Hello Year 7. Today we're going to be looking at expanding brackets. First of all, I would like you to do a little starter. I'm telling you that n is equal to 7 and I'd like you to work out the value of all the given expressions that you can see below. Please press pause and then I'll go through the answers. Okay, I'm going to start at the top with n squared. 7 squared is 49. I'm moving over to the left. That means 3 lots of n squared, so 3 lots of 49, which is 147. I'm going to go to the left, so I've got 2, and then that means multiplied by 7 add 7. So I've got 14 lots of 2, which is 28. Moving down, I've got 4 lots of 7 divided by 2. I think that's the same as 28 divided by 2, which is 14. On the next one down, that's 5 lots of 7, take away 1, so that's 35 take away 1, which is 34. Moving across, I've got 21 take away 2 lots of 7, which is 21, take away 14, which is just 7. The next one, I've got 4 lots of 7, and it's got a 2 outside, so we'll have to assume that means multiplied by 2, which is 28 times 2, which is 56. And then we've got 3 lots of 7, which is 21, and 7 add 5, which is 12. I hope you got those right. Let's move on to task 2. Right in front of you is a rectangle. One of the lengths is 3 units, and another one of the lengths is a unit. I'd like you to write down an expression for the perimeter, where the perimeter is the distance all the way around the outside of the shape. Okay, so I'm going to do it as well. Now, in a rectangle, I know the opposite sides always have the same lengths. So I know that the bottom side, the base, must be 3, and the other height must also be a. If I'm starting at one corner and walking all the way around my shape, I can see that the perimeter is going to be a, add 3, walking down, add another a, walking across, add another 3. So I could write the perimeter like that if I wished to. If I wanted to, I could write it a, add 3, add 3. But because we've been doing algebra recently, you and I both know that a and a is 2 lots of a, and 3 and 3 is 6. So I could also write it as 2a, add 6. There's also another way that I could write it, because some people add up the lengths of the 2 sides they can see. And if I did that, I would be adding 3 add a together. Now, if I added 3 and a, I would know that I've also got another 2 sides that would add together to make 3 add a. So a quick way of finding the perimeter of a rectangle is to add those 2 sides that you've been given and then multiply that by 2. So 2 lots of, in brackets, 3 add a. With algebra, I don't bother with a multiply, so 2 lots of 3 add a is going to give me the same answer as if I'd have written 2a add 6. I could have also written 2 lots of a add 3, give me the answer of 2a add 6. I wonder if you can see a relationship between the 2 lots of a add 3 in brackets and the 2a add 6. Let's have a look at the next one. So I'd like you to write down an expression, or as many expressions as you can, to describe the perimeter of this rectangle. Okay, I know that the opposite side of B is B and the opposite side of A is A. So I could write down the perimeter as A add B add A add B. I could also write that as 2 lots of A add 2 lots of B. But if you did it the quick way, and I know one length is A, and then I know one length is B, I could add up the A and B first, and then, because I know the other 2 sides are the same, as those, I could multiply that by 2. So I could write down 2 lots of, in brackets, A add B, which gives me the same answer as 2A add 2B. I wonder if you can spot a pattern in the expression with brackets and in the expression without brackets. Let's have a look at task 4. Now here I've got a lot of numerical expressions and I'd like you to match up expressions that mean the same thing. Please press pause and then I'll go through it. Okay, so I'm going to take C. And if I have a look at C, in the brackets 30 take away 3 is 27. So I know C means 8 lots of 27. I'm going to have a look to see if I can see 8 lots of 27 somewhere else. And I'm going to highlight C in yellow. I'm going to try and find another expression that means the same thing. If I look at K, I've got 27 lots of 8. So I know, of course, that they must mean the same thing. But if I have a look at J, I can see that 30 take away 3 multiplied by 8 is the same as K, 27 lots of 8. So I think J, K and C are all the same. I'm going to have a look at G. I can see that G is 12 lots of, in brackets, 18. So using a different colour this time, I'm going to highlight G as being 12 lots of 18. Now it doesn't matter which way I write round multiplication, so I can see that E is the same because that's 18 lots of 12. And if I have a look at D, I can see that 10 lots of 12 add 8 lots of 12, I think is the same as having 12 lots of 10 add 8, which is going to be the same as G. So I've got another 3 that match. Let's have a look at another one. I'm going to have a look at B, and in brackets 28 lots of 7. In a different colour, I'm going to highlight that one. Now, if I look at A, I've got 20 lots of 7 and 8 lots of 7, which means that I've got 28 lots of 7 in total. So I know that A and B mean the same thing. And if I have a look at H, 7 multiplied by 20 add 8 is exactly the same as those two. So I'm going to colour that in blue as well. Now I've got 3 left. I can see that I is 28 lots of 7. So I think that's the same as H, B and A. And if I have a look at F, I can see that I've got 18 in bracket lots of 12. So I need another green pen. So I've matched 4 that are the same there. And if I have a look at the bottom one, I do believe it's going to be yellow, because 30 lots of 8 subtract 3 lots of 8 is the same as 27 lots of 8. So did you manage to match up those correctly? I hope so. Now, for my 5th task, I'd like you to figure out how you would express the area of each of these rectangles if I gave you the dimensions that you can see. For the first rectangle, it's the area of the entire thing, but for B, it's only the deeply shaded area. The little hatched bit on the right hand side has been cut off. Okay, so for the first one, if I was going to be working out the area of this rectangle, I think that I would want to find the area of each one and add them together. So I could work out 7 lots of 8 first. So I could work out 7 lots of 8, which is 56. I could also work out the other rectangle if I know that it's 20 along the base and 7 high. So 20 lots of 7, which is 140. So if I were to find out those areas, I've got 20 lots of 7. Add, I'm going to write it the same way round, 8 lots of 7, which is going to give me 140, add 56, which is 196. I could have done it another way. The quickest way would be to notice that 20 add 8 would be 28. So I could have done 28 lots of 7. But to make 28, I added 20 add 8 lots of 7, which is the same as 7 lots of 20 add 8. I know this is the same as 7 lots of 20 add 7 lots of 8, which of course gives me the same answer as 196. So I have an expression involving brackets and an expression not involving brackets. I asked you to see if you could spot a link earlier. Can you spot a link between the expression in brackets and the one underneath it highlighted in yellow? The next one, you had to find the area of the dark green rectangle. Now, one thing I could do if I was trying to work out the area of the dark green rectangle is to work out the area of the large rectangle. And if I had to do that, I would do 30 multiplied by 8, which would give me 240. But because I'm taking away this hatched area here of 8 multiplied by 3, I've got the area of the small rectangle. I'm going to write that down, which is 3 lots of 8, which is 24. Now, if I want to find just the area of the shaded rectangle, I'm going to write down area of the shaded rectangle. And what I'm going to do this time is I'm going to explain that the shaded rectangle is the one in dark green. I would have to do the large rectangle's area subtract the small rectangle's area, which would be 216 units squared. So 216 would be the answer. But I've actually got a much easier way to do it. Because you and I know that 30 subtract 3 is 27, I could of course done 27 multiplied by 8, which is also 216 units squared. But what I could have done is, to find the area, I could have done 30 lots of 8 subtract 3 lots of 8. This is the same as 30 subtract 3 lots of 8, or 8 lots of 30 subtract 3. And earlier, when we found the area of that shaded rectangle, I said that we had to do 8 lots of 30 subtract 8 lots of 3. So again, I have a relationship between an expression with brackets and an expression without brackets. So this is an algebraic skill that's really important, expanding brackets. Could you work out calculations? Could you write down calculations for working out the area of these rectangles below? Let's have a look at the first one. We've got some algebra going on here, not just numbers. Now I can see that the first rectangle is D multiplied by 4, D times 4, and the second rectangle is 8 multiplied by 4. So one way of finding the area is to do D times 4, add 8 lots of 4. I could write that as 4D, add 32. But if I was having a look at the entire length of the base, I would see that that's D, add 8. I think that this area is the same as D, add 8 lots of 4, or 4 lots of D, add 8. When I have an expression with brackets in algebra, I'm going to show you that I can multiply each of the values inside the bracket by the term outside the bracket, which means that you get the same area. If I multiply 4 by d, I get 4d's. And if I multiply 4 by positive 8, I get positive 32. And as we've seen before, that's exactly what the area of this rectangle was. Have a go at the second one by yourself. Okay. Now, if I can see that the length of this rectangle is t, then the length left over must be t subtract 4. So if I'm trying to work out the area of the dark shaded rectangle, it's going to be t subtract 4, which is its base, times its height of 5. In algebra, I prefer to write that as 5 lots of t subtract 4. Now, if I needed to expand the brackets, I need to multiply each term inside the bracket by the term outside the bracket. This is called expanding brackets. So I'm now going to expand the bracket, and I get 5 lots of t, which is 5t's, and 5 lots of negative 4, which is subtract or negative 20. And that's an area expression for my second rectangle. Here it says, by drawing models of these expressions, expand the brackets. I don't mind if you draw a model or not, because I've taught you a way that we can always expand the brackets. Can you see if you can expand the bracket for 3 lots of x plus 4 from what you can remember? I'm going to go through it. Remember, we just simply multiply each of the terms inside the bracket by the term outside. 3 lots of x is 3x. 3 lots of positive 4 is positive 12. Having a look at B. 3 lots of 5x add 4. Please try these yourselves while you press pause, but I am going to go through them now. So I'm multiplying all the expressions inside the bracket by the expression outside. 3 lots of 5x is 15x, and 3 lots of positive 4 is positive 12. Looking at C, 3 lots of 5 add 4x. Again, multiply the terms inside by the term outside the bracket. So I've got 3 lots of 5 is 15, and 3 lots of positive 4x is positive 12x. Looking at D, I've got 3 lots of 4 add 5x. Multiplying each of the terms by the term outside the bracket gives 3 lots of 4, which is 12, and 3 lots of 5x, which is 15x, but I've got a positive 15x to write down there. Have a look at task 7. It says draw models for the following and hence expand the brackets. I don't mind if you just expand the brackets from the rule that I've given you. Have a go and press pause. Okay, so it's exactly the same as before. We're multiplying all the terms on the inside of the bracket by the term on the outside. X multiplied by x means x multiplied by itself, which is x squared. X multiplied by negative 1 is negative x. B. X multiplied by 2x add 1. Multiply the x by the 2x gives 2 lots of x squared, and multiply the x by just 1 gives us 1x, or add an x. C. X, lots of 2x, add y. I'm going to multiply by the term outside. X multiplied by 2x is 2x squared, and x multiplied by y is going to be positive xy. For task 8, in each group of 3, decide which expression is the odd one out and give your reasons why. I'm going to let you have a bit of time to find out your answer. Please press pause. Okay, if I have a look at the first expression in set A, that's p squared, add p, because I'm multiplying p by the terms inside the bracket. If I have a look at the second expression, 2p subtract the p at the end is going to give me 1p. P add p squared is the answer. Now those two expressions are the same, but 1 add p squared is definitely the odd one out because it's different. Because of course the other two are both p squared add p. It doesn't matter which way round you write them. So 1 add p squared is the odd one out. And let's have a look at the second lot. 7c subtract 3. I can't do anything with that. 4c, I can't do anything with that. But 7c subtract 3c means I've got 4 c's left, which means that the bottom two are the same and 7c subtract 3 is the odd one out. Have a look at the last bunch of 3. Press pause. Okay. The only expression that I can actually do anything with is the second one. I'm going to expand the brackets. 2 lots of A is 2A and 2 lots of 5 is 10. So 2A add 10. I can see the first and the second two expressions are the same, which leaves 2A add 5 as the odd one out. And finally, in each case, there is a mistake. Can you spot the mistake and write out what the correct method should be? Okay, I'm going to go through it. It's really important that you remember that the term outside the bracket is always multiplied by each of the terms inside. So I agree with the 3w, but 3 lots of 4 is 12. So I think the mistake was the positive 4 at the end. With b, remember that we have to multiply each time. So 8 multiplied by c is 8c, and 8 multiplied by negative 6 is negative 48. I wonder what the mistake was there. Maybe they did 8 subtract 6, which is 2, and then multiplied that by the c. Let's have a look at c. Remember, I've got to multiply the terms by the value outside the bracket. So 4 lots of k is 4k, 4 lots of 2 is 8, positive 8. But I can only add k's to other k's. I can't add 4k's and 8 together. I think the mistake here is that they added 8k to 4k to give 12k, but 4k add 8 is correct. 12k is not. On the last one, remember that we have to multiply the term outside by the terms inside. b multiplied by b is b times itself, which is b squared, not 2b. And b multiplied by 6 is add 6b. So the mistake there was the 2b. I hope you get on well with the work that I've set you on Show My Homework. Good luck and let me know if you need any help. Bye bye.